Okay, so in this problem, I've got a steel sleeve brass core. Okay, it's applied to a torque. Okay, I have the shear moduli of everything. I have the allowable stresses for each one. I want to find the maximum amount of torque that can be applied to this. So what I know to be true is basically the total torque is spread over the steel and the brass. So my statics equation will be just that the torque equals the torque of the steel plus the torque of the brass. Now, of course, I need to find those two to find that torque, but that's basically the statics equation that I'm looking for. Now, the other thing that I know is the compatibility equation, which is that the twists of these guys have to be exactly the same, right? They're linked together, so as they twist, they're going to twist the same amount. Both the sleeve as well as the core, the steel and the brass, are going to hold the same thing. So when looking at that, I'm going to go ahead and write these equations. So start with the steel, which will be torque of the steel times the length, which is going to be the same for both. It'll ultimately cancel out. And then that'll be divided by jg, where j, this is the steel is the sleeve, so it's going to be pi over 2 times outer to the fourth minus inner to the fourth, which is going to be 0.025 to the fourth minus the inner, which is 0.02 to the fourth. Again, outer diameter is 50, inner diameter is 20, so those radii are 0.025, 0.02 to the fourth. Now, the G for steel, again, given in the problem statement, is 80 gigapascal. So that's going to be 80 times 10 to the ninth. Okay. Now this has to equal TL over JG of the brass, which is going to be, again, the torque of the brass times the L, same length, right? Because the core and the sleeve have the same length. But this guy is solid, so it's going to be pi over 2 times the radius, which is 0.02 to the fourth. Then times its G, which is given in the problem statement, is 36 times 10 to the ninth. Again, lengths are the same, so those cancel. Okay. Denominators are a number, and then times TS and TB. When going through the algebra on this, I learned that the torque of the steel has to be equal to 3.203 times the torque of the brass. So the steel is seeing about 3 times as much torque as the brass for this for them to have the same angle of twist on them. Okay. Now, I still don't really have an answer yet because, again, I'm looking for torque, but I know that the allowable shear stresses are given. So from those, okay, I'm going to find torque of the shear stress of the steel is just going to be the torque of the steel times C over J. Now, knowing that the allowable stress in the steel is 80 megapascals, so that'll go 80 times 10 to the sixth. And that's going to equal times the torque in the steel times C, which for this is going to be the outer diameter. J, again, for the sleeve is going to be pi over 2 times 0.025 to the fourth minus the inner, just like we did before, like so. Okay, so from that equation, I can learn that the torque in the steel cannot be any bigger than 1,159 pounds. I'm going to do the exact same thing for the brass. Okay, the allowable stress in the brass is 48 megapascals, given in the problem statement. So 48 times 10 to the sixth equals TC over J for the brass, where T is, again, what I'm trying to find. C is 0.02, right, because it's the inner core, and then it's solid, so it's pi over 2. Okay, that's for the J. Okay, so from that, I can find that the allowable torque on the brass can only be 603. So from this, okay, I know, here are the equations that are important, right? Here's my statics equation, right? Here's my compatibility equation, okay? So I know that the steel is 3 times bigger than the brass. So if the brass is 603, then the steel has to be 1800, right? Well, that can't happen, right? The steel can't be 1800, right? So essentially what I'm saying is it can't be that, which means that it is this guy. And from that guy, knowing that brass has to be basically 1/3 of that, okay, I'm going to divide that by 3.2, and I'm going to find that the torque in the brass has to be 362 pounds. Okay? And again, I know that because from the compatibility equation, I know that the torque in the steel has to be 3.2 times the torque in the brass, right? So I can't, but I know that the steel can't be bigger than 1159, the brass can't be bigger than 603. So you see here that if steel is 1159, the brass is 362, which is less than the 603. Had I done the opposite, the steel would have been too large, right? So the limiting factor is that steel. Okay, so I set everything to that. Okay. Then adding those two together, I can find that my allowable torque is then just 1521 pounds. Okay, so again, start with statics. Know that the torque in each thing adds up to the total torque. Know that the twist has to be the same for each, so I can find the relationship between those two. Then find the allowable torques, knowing the allowable stress. Okay, and then knowing what they're allowed to be, knowing the relationship that they have to be, I know that the 1159 steel is what limits this thing. So the brass is 362, which is going to be less than its allowable, which is good. Adding those two torques together, I get the 1521.